For millennia, humanity has craned its neck, gazing up at the celestial tapestry of the night sky, a canvas speckled with stars. From the dawn of consciousness, these distant lights have sparked our imagination, fueling myths, legends, and a profound sense of wonder. In the face of such immensity, the question echoes through the ages. Are we alone in this vast, awe-inspiring universe? Is our pale blue dot the sole harbour of life amidst an endless cosmic ocean? This fundamental question, etched into the very core of our being, has driven our curiosity and scientific endeavours for generations. It has spurred us to build telescopes, launch satellites, and develop theories that attempt to explain our place in the cosmos. The relentless search for life beyond Earth is not merely a scientific pursuit, it is one of humanity's greatest quests, a testament to our insatiable desire to understand our origins and our destiny. It represents the hope of finding kinship in the vast emptiness of space. With each technological leap, from the invention of the telescope to the deployment of sophisticated space observatories, our vision extends further into the depths of space, revealing wonders once unimaginable. We are constantly pushing the boundaries of what we know and what we can see. We've bravely sent probes to the very edge of our solar system, venturing into the unknown, but the ultimate goal, the holy grail of space exploration, has always been to find another world like ours, a planet capable of supporting life. Then, in a moment that redefined our cosmic perspective, we found Proxima Centauri, our closest stellar neighbour, a mere 4 light-years away. This discovery brought the dream of interstellar exploration tantalizingly closer. Orbiting this faint red dwarf star is Proxima B, a planet residing in the habitable zone. That sweet spot, where temperatures are just right for liquid water to exist on its surface, a crucial ingredient for life as we know it. Its groundbreaking discovery transformed a distant hope into a tangible destination, a world we could potentially study in detail and perhaps one day even visit, bridging the gap between science fiction and scientific possibility. Proxima B rapidly became an object of intense fascination for scientists and dreamers alike, a potential neighbour, a cosmic companion in the vast, often lonely expanse of the cosmic dark. We focused our most powerful instruments, our most advanced telescopes and radio arrays, on this enigmatic world, meticulously searching for any telltale sign, any subtle anomaly that might indicate we are not in fact alone. And then, in the quiet hum of our observatories, amidst the blinking lights and complex data streams, something extraordinary, something truly remarkable began to unfold, hinting at a profound shift in our understanding of the universe. The universe, it seemed, was finally about to answer our oldest, most persistent question. The search for life beyond Earth had just taken a dramatic, potentially revolutionary turn, promising to reshape our place in the cosmos forever. The discovery didn't come as a dramatic signal, like a blaring horn announcing its presence. It wasn't a clear, easily decipherable message beamed across the vast gulf of space. The universe rarely offers such straightforward revelations. Instead, it arrived as a subtle anomaly in the data, a whisper amidst the noise, a faint echo hinting at something extraordinary. It was the kind of signal that could easily be missed, dismissed as a glitch or attributed to some mundane source of interference. Dr. Aris Thorne and his team at the Atacama Large Array first noticed it. Their sophisticated instruments, perched high in the Chilean desert, were uniquely positioned to capture these faint signals from the distant star system. It manifested as a series of unusual, rhythmic light emissions emanating from Proxima B's dark side, the hemisphere perpetually facing away from its star. This was particularly intriguing, as any natural light source would be expected on the illuminated side. At first dismissed as noise, a common occurrence in astronomical observations, the signals persisted. They weren't random or chaotic. Instead, they clustered in specific regions, flickering with a strange regularity, a pattern that defied easy explanation. The team began to suspect that something more was at play. Cross-checks with other observatories around the world were crucial. Data from independent sources was needed to rule out any local interference or instrumental errors. To their astonishment, the other observatories confirmed the lights were real, solidifying the initial findings. The team meticulously catalogued thousands of these points of light, each one a tiny beacon in the darkness, carefully noting their positions, intensities, and temporal variations. As the data accumulated, a remarkable pattern began to emerge. The lights were not scattered randomly, but instead forming vast, interconnected networks across the planet, like glowing threads woven into the fabric of Proxima B. Some clusters resembled city lights on Earth, sprawling urban centres pulsating with activity, suggesting a similar concentration of energy and perhaps even civilization. Others traced what could be coastlines, illuminated by some unknown technology, or perhaps mountain ranges, their peaks adorned with artificial lights. The patterns were undeniably complex and persistent, unlike any known natural phenomenon observed on Earth or elsewhere in the solar system. This was not the aurora borealis or volcanic activity or any other geological process. On January 8th, 2025, after months of rigorous analysis and careful deliberation, Thorne's team published their findings in a prestigious scientific journal, sending shockwaves through the scientific world and igniting the imaginations of people across the globe. The evidence widespread organized light sources on Proxima B's surface was compelling, even if its interpretation remained uncertain. The paper was meticulously cautious, avoiding any sensational claims, but its implications were explosive, hinting at possibilities that had previously been confined to the realm of science fiction. It didn't explicitly claim the existence of alien life, but pointed to a mystery so profound, so utterly unprecedented, that many hesitated to speak its name, fearing ridicule or disbelief. For the first time in human history, humanity wasn't just passively looking at a distant planet, wondering if it might harbour life. We were looking at a world that might be looking back, a world that potentially held civilizations capable of generating light on a planetary scale. The cosmos, once perceived as a silent, empty void, had just become a little less silent, a little less lonely. The long and arduous search for life beyond Earth had perhaps found its first real, tantalizing clue. A beacon in the darkness, beckoning us to investigate further. Everything we thought we knew about our place in the universe had changed in an instant. Observing Proxima B, a planet orbiting a star far beyond our Sun, is an astronomical challenge of immense proportions. It's akin to spotting a firefly beside a searchlight from miles away, an almost impossible task given the vast distances and the overwhelming brightness of the star. The faint light emitted by the planet is easily lost in the glare. The breakthrough came with the development and refinement of stellar coronography and adaptive optics. These technologies represent a monumental leap forward in our ability to observe exoplanets. Stellar coronography works by meticulously blocking the star's intense glare, creating an artificial eclipse that allows the much fainter light from orbiting planets to become visible. Adaptive optics then steps in, sharpening the planet's faint light by correcting for atmospheric distortions. The James Webb Space Telescope, with its unparalleled capabilities, provided crucial spectroscopic analysis, breaking down the light from Proxima B into its constituent colors. This allowed scientists to analyze the chemical composition of the planet's atmosphere and surface. Scientists detected a broad spectrum of illumination emanating from the planet's night side, a range of wavelengths that hinted at something extraordinary. The spectrum was consistent with various forms of combustion and, remarkably, electrical lighting. This was an unexpected and potentially groundbreaking discovery. This synergy of ground and space telescopes, working in perfect harmony, allowed us not just to see the lights, but to begin to characterize them with unprecedented detail. We meticulously measured their intensity, catalogued their color variations, and mapped their distribution across the planet's surface, creating a detailed picture of the illumination patterns. Decades of relentless innovation, pushing the boundaries of what's possible, had finally given us the tools to glimpse another world's night, revealing secrets hidden for eons. And through these newly opened eyes, peering across the vast cosmic gulf, we saw something truly extraordinary. Something that could change everything we thought we knew about life in the universe. Once the lights were confirmed, scientists raced to explain them. Theories ranged from bioluminescent magma to glowing microorganisms or minerals fluorescing under Proxima Centauri's flares. But these ideas struggled to explain the structured, geometric patterns, grids and clusters, not random shapes. The lights resembled satellite images of Earth at night, dense concentrations, connecting lines, deliberate distribution. The simplest explanation? Technology, cities, transport networks, industry. If true, it means a civilization has arisen next door, illuminating its world. The implications are staggering, and science approaches them with caution. But the evidence points to something organized, something artificial. Humanity was on the brink of a new era. The prospect of intelligent life is thrilling and deeply unsettling. We know nothing of their nature. History warns us of catastrophic encounters between unequal civilizations. The lights could be remnants of a lost society, or evidence of beings who survived Proxima's violent flares by retreating underground. A civilization thriving in such harsh conditions might be far more advanced or more ruthless than ours. The discovery could unite humanity or fracture it with fear and suspicion. The lights of Proxima B are a mirror, reflecting both our hopes and our deepest anxieties. The news spread worldwide, igniting awe, excitement and anxiety. Landmarks were lit in tribute. People gathered to gaze at the sky, pondering the enormity of the revelation. Scientists mobilized, observatories focused on Proxima B, and interdisciplinary teams formed to interpret the lights. Public reaction was divided. Hope and wonder clashed with fear and suspicion. New movements and ideologies emerged, some calling for contact, others for silence. The debate over whether to reach out or hide our presence became urgent global policy. The lights on Proxima B illuminated not just a distant world, but the divisions within our own. The discovery has forever changed humanity's trajectory. We now see ourselves as one of two known inhabited worlds in the galaxy. The drive to learn more will accelerate innovation. Bigger telescopes, new propulsion and interstellar exploration. Projects once considered science fiction are now serious pursuits. The next generation will grow up with Proxima B as a real place, not just a point of light. The lights challenge our science, our unity and our imagination. Whether they represent danger or opportunity, they give us reason to look up and forward. Humanity's story is now part of a larger cosmic narrative. We stand at a turning point in history. The darkness has blinked back and the silence is broken by a distant glow. The lights of Proxima B have given us the greatest mystery we've ever faced. The journey to understand them will take decades, perhaps centuries, but it has begun. This is not just a scientific quest, but a human one touching the core of what it means to be alive in the universe. The cosmos is full of wonders, and our shared voyage has just begun. For Cosmic Discover, thank you for joining us on this journey.